Algebra 2, 3.2, Solving Systems of Equations by Substitution and Elimination. So we're first going to focus in on the substitution method. So the substitution method is going to be where you solve for one variable in one of the equations and then plug that expression into the other equation. So what you want to look for is the variable that has like a 1 in front of it. Like this one, the y has a 1 in front of it, so that's what we want to do. So we're going to solve for y in the first equation. So if we do that, we get, all we need to do is move the 2x over to the other side, and you can think of it as y. It doesn't need to be 1y, so we're going to add the 2x to the other side. So that's my step 1. Step 2, I'm going to substitute that expression into the other equation. So since we were working with the first equation, we're going to plug that expression into the second equation. So 3x plus 2y equals 9. So if you can remember back from geometry, when we're doing the proofs, this would be like where we would justify it by substitution. Okay, so instead of 2y here and the y here, it's like we're getting rid of those y's. We're replacing the y with the 2x plus 8. Okay, so from there, we're going to solve. Okay, so just solve for x. You can distribute the 2 through. So you get 3x plus 4x plus 16 equals 9. Add like terms. Oops. There we go. We can subtract the 16. So we get 7x equals negative 7. One last step, divide both sides by 7. So x is negative 1. Okay? So in your answer, still going to be an ordered pair. So our x is negative 1. Now we just need to figure out what was y. All right, so now we're on to step 3. Substitute your answer into one of the original equations, and it doesn't matter which one you choose. So we're on step 3. So we're going to take that negative 1 and put it into one of the original equations. Or you could put it in the equation that you found in step 1 there. And I think that's what I'm going to do. So in step 1, when I solve for y, I got y equals 2x plus 8. But now that I know x is negative 1, I can fill that in. So what was x? X was negative 1. So now we can figure out what y is. So y is 6. And that's your ordered pair. Okay. All right. Now if I would have graphed this out, this would have given me the same. We could have done it just like we did yesterday. But we don't need to do it like that. This is just another method. So if I would have graphed it out, y equals 2x plus 8, might look something like this. And the second equation would end up being y equals negative 3 over 2x minus or plus 4.5. Maybe something like that. And so you can see where are they going to cross? They're going to cross at negative 1, 6. Okay, now we don't need to do the graphing part. But that just kind of pulls in what was different about what we did yesterday. Another thing you can do, again, optional step here, is this step 4. Check your point to make sure it works. So maybe we could take the second equation there, 3x plus 2y equals 9, and plug in your point. So our point was negative 1, 6, and just make sure that it makes the expression true. We want this point to work for both equations. So again, you don't need to do that step. That's not your answer. Your answer is just the ordered pair. All right, let's go down to example 2, and then why don't you guys go ahead and pause the video and see if you can solve it. All right, so example 2 should end up being negative 5, negative 4. If you did not come up with that answer, You might check over here when you distributed the -5. A lot of times there's an error with that step because we have to take -5 times 4 and -5 times 11. So just check that step. All right, let's go to the other method. So these were both solving by substitution. We're going to look at solving by elimination. All right, so if I want to solve a system by elimination, what I want to do, step 1 is, first of all, hopefully the equations are set up right. You want them to be in standard form, ax plus by equals c. If needed, multiply one or both equations by a number that will eliminate x or y. Make sure one of the coefficients is a positive and one of the coefficients is a negative. So when I look at what we're actually going to do is just add these up and try to get either the x's to cancel or the y's to cancel. Okay, but right now they don't cancel because they're not the same number. So we're going to try to make them be the same number. So if I want to think about getting rid of these x's, one is like a -1 and one is a 2, we could make those both be 2's and then they would be the same number. Okay, I'll show you how to do that here in just a minute. If I wanted to eliminate the y's, we could make both of those be 3's. Okay, so how are we going to make both of them be the same number? All right, let's eliminate y, or x. I'm going to eliminate x. So step 1, let's eliminate x. Okay, and you don't usually pick it just by choice. Usually look at the numbers and pick it. So I'll show you why I picked x. So step 1, if needed, multiply one or both equations by a number that will eliminate x or y. So step 1, we're going to multiply the second equation by 2. Okay, the reason you can do this is because we're taking both sides of the equation by 2. And as long as we do it to both sides on an equation, we can do it. So let's take that second equation and multiply it by 2. So if I distribute that 2 through, I end up getting -2x plus 6y equals -24. Okay, so now we're on to step 2. What we're going to do is add our equations. So that was our second equation. Let's get that first equation back up there. So our first equation was 2x plus y equals 3. And then let's go ahead and add these up. So if I add -2x plus 2x, that's where we get our canceling out, our elimination. 6y plus 1y, that would be 7y. -24 plus 3, -21. Okay, so we can finish this up by, I should say, add your equation to eliminate a variable and solve. Okay, so we can divide by 7. So we get y equals -3. Okay, and we actually need to plug that back in to see what the x would be. So plug y in to get your x. And we do this the same way that we did the substitution. It's just that first step that's different. So if I plug my y back in, I'm going to get, you can plug it into either equation. So if I pick the 2x plus y equals 3 equation, and we had that y was -3, it would look something like this. 2x plus what equals 3? Well, y we said was -3. So now just solve that. So we add our 3 and get x to be 3. So then write your answer as a point, 3, -3. All right, let's talk about the next one before you guys get started with it. So for this next one, we need to actually multiply both equations by some number. So it's kind of like thinking of the least common multiple of the two numbers. So like if I wanted to eliminate these x's, I want to make them be a 6x or a negative 6x. Okay, because the multiples of 2 and 3, the first one in common is 6. If I wanted to eliminate y, the first one in common would be 20. So decide whether you want to eliminate x or y. It doesn't matter which one you choose. Just pick one. So I'm going to eliminate the x's. Okay, so instead of just multiplying one of our equations by some number, we need to actually multiply both of the equations by some number. So if I want the x's to be 6, I could take the first one times 3, and then I could take the second one. I want a negative in here, so I'm going to do it times a negative 2 so that I can add them and get them to cancel. Because if I do 6x and 6x, that will make it 12. We don't want 12. We want 0. All right, go ahead and distribute that 3. Don't forget to distribute it to all 3 items. From there, we can add our equations. And solve for y. All right, why don't you guys pause the video and then see if you can finish it up. All right, so if we plug in the -3, we should get our solution to be 4, -3. That's the only point that works for both of these equations. There's lots of points that work for the first equation, lots that work for the second, but that's the only one that works in both equations. All right, go ahead and look on Canvas to see the assignment for today.